Okay, quickly. How to write a good proof. Now remember, a proof is some kind of an essay that is supposed to convince the reader of something. And if it's not well written, it fails to convince the reader. Okay, it might leave the reader with some doubts. The proof has failed. Okay, it doesn't matter how correct the proof is. If it fails to convince, maybe because it's badly written, it has failed. Okay, so how do you write good proofs? Okay, so, the first thing you should do when you're writing a proof is state your strategy. For example, we're going to use a direct proof. Okay, remember, a proof should have a logical flow. Think about those movies where, jumping back and forth between storylines or jumping back and forth in time. Very hard to follow. Readers, go from the beginning to the end of a proof linearly. So you must have a logical flow in the proof. And, don't try to make things overly complicated. Keep it simple. Your proof has some key idea that should be clear. Okay? So avoid unnecessary notation, avoid excessive symbols. Don't try to show off in your proof. Your proof must convince, must leave the reader with no doubts. Okay? Justify every step. The reader must have no doubts. Okay? So if it's so obvious, don't say it's obvious that. If it's that obvious, give a quick explanation. Unless it really, really is obvious that, 2x is even. You say 2x is even. Okay? But otherwise, don't leave the reader with doubts as to why is that so obvious. Give the quick explanation. Okay? And your proof. So if it's a direct proof, you assume P. Now you need to prove that Q is true. Okay, so you say, and so we have proved that Q is true, concluding the proof. Okay, and last step, but very important, read your proof, check it for correctness, edit it, simplify if possible. Okay, now let's talk about picking a proof template, so picking a kind of proof. There's some, creativity there. There's something to be said there. So what I'm going to do is I'm going to present you with a situation, and I'm going to suggest a proof method. Okay, so we're mostly talking about, implications, but all kinds of other proofs also crop up. So let's start with an implication, P implies Q. We typically say that P is the assumption and Q is the result. Now, if it's obvious to you, if it's very clear how the result follows from the assumption. So the assumption is P, the result is Q. If the result clearly follows from the assumption, direct proof. Okay. Now, on the other hand, sometimes it may not be obvious that how the assumption produces the result. But it might be obvious that if the result is false, then the assumption would be false. Okay? Contraposition. Okay? Now, here's another situation. You want to prove that something exists. Okay? That's usually relatively easy. Prove that a unicorn exists. Go and find a unicorn and bring it to me. So, show an example. Okay? You want to prove that something exists? Show an example. You want to prove that something does not exist? Much harder. Okay? Prove that unicorns do not exist. So, what you do, you assume that there's a unicorn and then explore around and end up in some kind of dilemma, some kind of contradiction. So contradiction is usually the way to prove that something does not exist. Assume it exists, explore, come to a contradiction. Okay, you want to prove that something is unique. Again, very similar to proving that something does not exist. If you want to prove that something is unique, basically what you're saying is I have something and I want to show that there does not exist another thing like that. So you're trying to prove that something does not exist. Contradiction is a good idea. Okay? You want to prove it's unique. So you have something. Assume that there is another thing like that. Okay? And then come to a contradiction, which means that that assumption is false. There's no other thing like that. It means that what you have is unique. Okay? You want to prove that something is not true for all objects. So it's not true for all objects. Okay? So all you have to do is find one object where it's not true. Okay? Show a counterexample. Okay, so that's a counterexample. Someone makes a claim and you want to show that it's not true for all objects, find a counterexample. Okay, find one example where it's not true. Okay. You want to show that something is true for all objects. Okay. That's much harder. Okay. And we'll talk a little bit about that next time, but what you have to do is you have to consider a general object and show that it's true. Okay, so you can't limit yourself by saying, I'm going to consider this particular kind of object and show that it's true. You have to show it for all objects, so you have to show it for a general object. So show for a general object. Now, if you want some practice in picking the right proof template and getting used to that whole notion of looking at a problem, trying to figure out which situation you're faced with, and then pick the right proof method, try exercise 4.8 in the book. Solutions are on the web. Okay? Signing off. See you next lecture.